Yeah. So like I was saying again, I'm Emily Potosny, Sustainability Engagement Manager in the Office of Sustainability. And we're going to be talking about reducing plug loads at Pitt today, along with the Carbon Crushers research team. So we'll get started. So before talking about this topic specifically, it's important to kind of just frame what we're doing with sustainability at Pitt overall. So the university defines sustainability as balancing equity, environment, and economics so current and future generations can thrive. So it's recognizing that each of these three pillars has to support our overall sustainability programming. Without each of them working in tandem, the initiatives that we work on really can't stand the test of time. And that current and future generations portion is really important for us as a higher education institution, as that's our mission as well. So a little bit about Pitt's path to sustainability. It started more than 30 years ago at this point. We were one of 22 institutions, universities globally to sign the Tellwar's Declaration, which was the first kind of recognition of the importance and role that higher education can play in addressing the climate crisis. In the time since then, we've had a lot of different initiatives that the university has taken on. Most notably for this presentation is when we started conducting our greenhouse gas inventories as a university in 2008. And so this is a real accounting of all of the emissions associated with Pitt's operation. And we've conducted one of those every 3 years since 2008. And our most recent one was in 2021. Also notable in here, we're going to be talking about Pitt's sustainability plan today, which was released for the first time in 2018. We also just released our first progress report on the 68 different goals that we have within that sustainability plan. And then finally, we also committed to being carbon neutral, so full carbon neutrality by 2037 in 2020, and developed our first climate action plan that details how we're going to get there just last year. So a bit more about that sustainability plan. It's in 3 different themes with 15 different impact areas and those 68 individual metric goals, like I was mentioning. The one goal that we're going to be talking about for the most part today is within the stewardship section. And that goal in 2020 was to reduce greenhouse gas emissions 50% by 2030 from our 2008 baseline. And then in 2020, we added on achieving carbon neutrality by 2037. So this here is our fiscal year 19 greenhouse gas inventory, just kind of a snapshot of it overall. We have much more detailed information on this available on our website if you'd like to dig in. The reason why we're using the fiscal year 19 inventory for reference here rather than 2021 is that 2021 was heavily influenced by the pandemic. So we see, significant reductions, especially in the connecting our community section in the 2021 inventory because people weren't commuting as much for work. So as more of like a kind of realistic baseline to refer to for this discussion, we're just looking at this fiscal year 19 inventory. You can see here that more than 60% of our greenhouse gas emissions can be associated with what it takes to power and energize our campus. So that includes, everything that requires electricity, whether it's our HVAC and lighting systems, our plug and process loads, or moving air around our buildings as well. So the vast majority of that is purchased electricity. So that's electricity that we're purchasing from the grid, the same way that you do in your home, from Duquesne Light or, a similar provider. And then we also do have on-site district energy from our steam and boiler plants that are in Oakland. So yeah, the vast majority there is from that purchased electricity. So noting that, most of our greenhouse gas emissions do come from energy. We focus a lot of our resources in the Office of Sustainability and, as a university on how we're going to reduce that electricity and energy use. And it's great to note that the last time that we did a sustainability culture survey, which we do every 3 years at the university to try and get a sense from the Pitt community about what's most important to them related to sustainability, is that we're meeting what Pitt cares about most. in terms of what we can do for sustainability as a university. So the top three pressing issues that were identified by the Pitt community in the 2020 survey, the top of those was energy use efficiency and conservation. I should note as well that we are now doing our third sustainability literacy and culture survey. It's live right now on our website. And I'll have a link for you guys a little bit later in the presentation. So you can take that survey and have your opinion be heard this next time around. All right, so our climate action plan, like I mentioned, was put out to the public in 2022. And so within that climate action plan, we're detailing really our pathway to how we're going to reduce our emissions and reach carbon neutrality by 2037 in a realistic and fully documented way. So the three priorities that we have to meet those goals are to reduce our energy demand, which is largely what we're talking about here, switching our supply of electricity to clean renewables. So that means switching a lot from that purchased grid electricity to more renewable generation that Pitt is purchasing, has on site, and things like that. And then also switching to more low carbon connections, so low carbon transportation options throughout the university. So this waterfall diagram gets into how we're actually going to do that. So you'll see on the left here, these gray bars show Pitt's actual energy or greenhouse gas emissions based on the most recent inventory that we'd conducted prior to creating this plan, which was 2019. Along with expected growth. So we anticipate that the university is going to grow, increase student attendance over time, probably increase in some degree of square footage that the university owns for buildings. So we have expected growth factored in there too. And you can see here, each of these segments of the waterfall diagram details different strategies that the university has planned for and accounted for to reduce our greenhouse gas emissions. And then we've calculated the real reductions in those emissions with each of those strategies. So you'll see all of the segments that are in solids are things we've accounted for, that we have plans for in place. And where we have hash lines, that's things that we have yet to figure out, that's yet to be procured for carbon reductions. So, we're still innovating and finding new solutions to account for what remains within this waterfall. So today, like I mentioned, we're talking about energy demand reductions as they relate to plug and process loads. And specifically, we're talking about those in existing and new buildings. So honing in on this section of the waterfall diagram. And I should say too that it relates to maximizing efficiency in existing buildings, but also someday down the line you might be moving into a new building that's high performance. So the university has been working since 2005 to optimize the efficiency of its building stock, and we've achieved LEED certification, which is a third-party certifier for energy performance and other efficiencies in the built environment. And so we've achieved 17 different LEED certified projects in that time, the most recent being our first LEED Platinum certification with the Sulk Hall renovation. And we have 13 projects that are in the process of being constructed as well. So, all of that said, the new buildings that we're constructing, I should have said, this is both renovations to existing buildings that can be LEED certified, and then also the university has made a commitment that any newly constructed buildings, including the new athletics and wellness and rec buildings going up on the upper part of campus, will be LEED certified from the outset. So as we're discussing what you can do in your office today, the plug loads we're discussing are part of an existing building efficiency. And so this here is an example of Pitt's energy use dashboard. It's one of 6 dashboards that the Office of Sustainability keeps on our website that we update with regular resource use data from buildings across campus. So the Carbon Crushers group today is going to be talking about Benedum Hall for their plug load inventory. And so here you can see an example of the energy use intensity. So that's kilo British thermal units per square foot. for Benedum, and it goes all the way back to 2014. So if you're interested in seeing this information for the building that you're in, we keep that publicly available on our website. On one of these dashboards, you can click around to the individual buildings on campus and get a sense for that energy use intensity per square foot. And if you want to go even more granular with that information, here's where that information comes from. So this is monthly reported utility information for Benedum Hall from Energy Star Portfolio Manager. So we track this information for every Pitt-owned building on campus, and it's publicly available as part of, since Pitt is part of the 2030 district in Pittsburgh. So you can look at this information for your own building if you're interested in like finding out how you actually like the total kilowatts per hour that your building uses. And if you want to see more of like a comparison for benchmarking compared to other buildings on campus, you can check out that dashboard information. And I'm always available, and folks over in the Office of Sustainability can help you kind of digest that information if you're ever interested in doing it on an office level or a departmental level or anything like that. So now getting a little bit more into the nitty gritty. So these are graphs from the National Renewable Energy Laboratory that detail in typical commercial buildings common energy use. So you can see the commercial buildings that we're referring to make up about 19% of total energy use across the US. And then about a third, 33% of the energy use in a typical commercial building can be attributed to plug and process loads, or PPLs. So you can see, a far greater portion relates to things that we don't typically think of as necessarily in our control. So that's our HVAC systems, heating, cooling, ventilation, and lighting. So lighting in some cases relates to individual use. But what we pointed out before, or what I pointed out before with our LEED buildings, as we expect that our buildings will become more efficient over time, the percentage of plug and process loads contribution to this pie chart is going to increase as those heating, lighting, and cooling systems become more efficient or are made more efficient over time. So that's all to say, what we're talking about today is really important now, and it will be increasingly important as the building stock that Pitt owns and also nationwide, our energy systems become more efficient in the buildings that we occupy. For a little bit more information about standby power, so the team's going to get a little bit more into that, but this is standby power is the energy used when your device is plugged in but not in use. And it's a relatively small portion of overall energy use, but when combined over hundreds and thousands of devices, it adds up to huge potential savings. And so this is a chart that from the Berkeley Lab, Standby Power Lab, showing the average range of standby power draws for some common office and household devices. So if you look at this, you can see that some of the largest draws are related to really televising and computing things. So set-top boxes is what's used to connect smart TVs and that kind of thing. AV systems, speakers, VCRs, gaming consoles, all of that kind of stuff. So you can look for, your common office devices on here and, think about this as I hand it off to the energy savings team or the Carbon Crushers team to talk a little bit more about what devices they saw throughout Benedum and some strategies related to that. So I'll hand it off to you guys now.
Good afternoon, everyone. This is the Carbon Crusher team, and we are in a class from the Pitt Sustainability class. Our group members are Tao Yuchen, Jack Moreland, Ran Van Pelt, and Ran Tickleman. We have the passion to reduce energy consumption, and our desire is to improve existing building efficiency. We found out that 23% of American power use comes from ideal plug load, which means that 23% of American power use comes from people forget to power off things, and 33% of energy use comes from commercial building use comes from plug loads. And we also found out that Pitt's goal is to reduce greenhouse gas reduction by 9.4%. So now let's give our floor to Jack Moreland to let him to explain more things about our research on Benedum Hall.
All right, so we ran an inventory on Benningham Hall to look for different types of data and utilities that are commonly plugged into these offices. So we chose Benningham Hall based off the energy use intensity from the Pitt Sustainability Dashboard, and we found that it was much higher than average based on like the 2003 standard. So we chose to do a door-to-door survey method, which which was very good, which helped us get a lot of information because we had the help of the Benedum staff to guide us around and show us rooms. Through this, we got a lot of information regarding utilities plugged in, and especially we were focusing on printers and monitors because we found that they draw high amounts of energy in off and standby modes. All right. And so in Benedum, the plug and process load energy and cost. So out of all the energy used in Benedum, 33% of that um 33% of that energy goes to PPLs. So this number is an average based on NREL standards. So this could possibly be lower according to Pitt's buildings, but this is just the average we used. So about 2,858,953.9 kilowatt hours is being used for PPLs. And the cost of this is $343,074.50.
Mhm. And I should note too, just for like a little caveat on that. So of course, Pitt's energy mix of how we actually power the buildings on campus is only a certain percentage purchased electricity, like we mentioned before. And so, within that, we have, different calculations for the energy that we're getting through district sources, from the steam and boiler plants, from the chilled water plants, things like that. So the actual costs and actual kilowatt hours are likely a little bit skewed from this, but just to give an overall sense of the potential costs and savings, I feel like it's a really, really helpful thing for us all to know. Are you ready for the next slide?
Yeah, so that last number was based simply just off the purchased electricity from Duquesne Light. And from there, we broke down the data even further to look specifically in office spaces and then specifically where we can get our reduction of 9.4% for more efficient building energy. So office spaces account for about 30% of PPL energy in Benedum Hall because of the sheer amount of laboratories, which take up just over 70% of the energy. We have a number of 857,668 kilowatt hours a year based on the 2022 purchased electricity data. And then if we reduce that by 9.4%, that would be a reduction of 80,622.5 kilowatt hours less each year. And that translates to an energy or a cost savings of 32,249 a year based on the 2022 data. Next slide, please. Mm-hmm. And so looking at two very commonly found devices throughout Benedum Hall, printers and monitors, they draw vampire energy just like any other device does. Our printer data has an estimated 250 kilowatt hour loss per year. And this is assuming all printers are in off mode all year long. So obviously, while in off mode, they do not draw as much energy as just standby or on mode. Standby power draw is up to 10 times as wasteful for most printers commonly found in Benedum Hall. And this equates to roughly 240 pounds of CO2 emissions wasted just from the vampire energy. Looking over to the monitor data, this was a little bit more of a struggle to find specifically for the monitors found in Benedum Hall because of the real difficulties of inventorying. Monitors are easy to find model numbers for, but they themselves do not draw vampire energy. It's the computer towers that do draw vampire energy, but many computer towers are hidden in below desks and spaces that are hard to find a model number for. So this is based off the Berkeley Lab standby power data that was previously shown before we took over the presentation. An average classroom has about 48 computers throughout Benham Hall. There's about roughly 10 classrooms, computing labs, and each one of them draws an average of about 11 or 1,135 kilowatt hours per year of standby power mode. And that's pretty typical considering that many of the monitors found throughout Benham Hall are just left on the home screen display. Sometimes they're used for classroom use as professors will display their presentation slides. But as an engineering student, I find that not all professors use this. So a lot of the monitors are truly left in standby mode for a full year. Furthermore, we completed an inventory of monitors found throughout the administration offices in the first floor. And with an average or an estimated amount of 75 computers throughout the first floor draws an estimated 1,770 kilowatt hours per year of vampire energy. So these are small numbers in compared to the 80,000 kilowatt hour per year of office space vampire energy in Benham Hall. But these are not the only two devices found throughout the entire building. So if we can reduce these energies over time, we will save money and wasted energy.
And pardon me. Here we have some observation of plugged-in devices, and a lot of these observations came from brief interviews and surveys with faculty at Benham Hall. So first, we found that there were many public printers, whether they were in copy rooms or just part of a big office layout. There's many opportunities for people to access public printers. However, despite this, most offices have private printers, and most people have private printers. And the number one reason for this was convenience. There was only a small amount of concern over the sensitivity of the data that would have to be printed. For the most part, it's convenience. And on top of that, most people use the printers in their offices maybe once a day, once a week, or once a month. The only person we talked to that really often used the printer was a receptionist. Also, we found that there are a lot of shredders that are plugged in and on standby mode. And this is despite not being policy to shred things anymore, but instead to dispose documents inside of those big bins with the slots in them for standardized document disposal. Also, a lot of university provided computers are slower than the laptops that were issued during COVID. We found faculty that did not use their computers because it just wasn't as good as their newer laptops. However, these computers often remained plugged in, and sometimes they were only plugged in so that they were able to use the public printers because the public printers weren't always obvious on how to access them and connect your private laptop or other device to the printer. And this kind of summarizes and points to that a lot of devices are legacy. This is even personal, private things, or the computers. There's just a lot of devices that are plugged in but not being used and aren't even going to be replaced, which shows that they're not very useful, but they're still drawing that vampire energy. And that's what we saw a lot from faculty. But as already mentioned, there's a lot of monitors, computers, and labs that aren't being used. In one computer lab, when we were talking with students, they said that only one class per year used that lab. And otherwise, those 30-some computers and monitors were on, the home screen just all the time. And now that we know this, we have some recommendations.
All right. And just for anyone who hasn't seen it yet or would like to take it, we do have the student survey of plugged-in devices in your office is still live. I'm going to include a link to it there. So if you'd like to take that survey and participate in their data gathering, you're welcome to. All right. So now I'll move on to some recommendations for how you can reduce plug loads in your office. And as with a lot of things when it comes to sustainability, the first thing that we really have to do is assess an inventory to figure out where we are at a baseline. So, there's inventories that you can do, like the one I just shared with you that the students put together. There are also resources available through the National Renewable Energy Lab that can help detail some cost savings potential through source reduction. Thanks for the note there, Doris. So you can use that as a way to track your devices, count them up, and then use average standby power draws and in use as well, power use to determine how many kilowatt hours your devices are using, and then multipliers based on kind of national standards. So that's that NREL link that's there, which I'll be sure to share out in a moment. So assessing those devices can help you to figure out how best to consolidate them. So like the students mentioned, a lot of devices, especially in this post-COVID working environment, are there because they existed in our office spaces before we worked with flex schedules or before we started using a lot more digital alternatives. So consolidating to just the devices that you regularly use and assessing which devices you regularly use can be a really important factor in just cutting down on those unnecessary devices. At Pitt, we do have a couple of different ways to get rid of those unneeded devices. So Pitt Surplus does offer electronic and e-waste, any kind of appliance or device pickup that can be arranged through your administrator. And then we also have an opportunity coming up organized by the Office of Sustainability with our annual Clean and Swap event. This is an event where you can come and drop off any used or unused office supplies, equipment, art, anything like that. And you can bring it there and dispose of it for no cost, so without the surplus pickup cost. And folks can also come through and look through the items that we have there and take them for free to use in their offices, so hence the Clean and Swap. We also partner with a number of nonprofit agencies to distribute what's left over at the end of the day through schools and other educational programming throughout the region. And then we also partner with Global Links for medical supply redistribution, since we do have so many lab spaces as well on campus. So after figuring out what devices you can part with, donating them and figuring out an end of life plan, making sure that you move devices to shared spaces. So one of the strategies that I'll talk about in a second is using advanced power strips to help manage your plug and process loads. And before you do any of that, figuring out how to consolidate your devices that do share common use times and use types will be really helpful. So if you find that you've got printers distributed in many places across your department floor or your shared office space, figuring out if you can consolidate that to a copy and printing area. Similarly with kitchenette items, if you have coffee pots in individual offices, seeing if you can consolidate that to a kind of cafe and kitchenette area. And also if you have, say, devices in your workstation that are spread out and have to use multiple plugs, seeing if you can consolidate those so that they could share a single power strip will be helpful as well. And then the next strategy is to implement plug load control strategies. The first and easiest of these that requires really no investment of anything beyond a couple minutes of your time is to make sure that you've programmed standby, hibernate, and shutdown policies and protocols in your devices. So you can set that up on your Windows computer if you haven't done it yet, and click through to your settings, make sure that you've adjusted your shutdown and hibernate times to what works the best for you. Like if you find that you leave your laptop and you need it to be on for a certain amount of time. I, for instance, have mine shut down after 4 minutes of inactivity and go into hibernate mode. So you can determine what would work best for you. But in many cases, folks haven't adjusted whatever policies in there automatically to suit whatever their actual use types are for those devices. Similarly, stand-up printers They do draw a lot of energy on standby, especially before we switched out to more efficient models. So making the switch there to make sure you've adjusted the protocols in your either desktop or stand-up printers to adjust for standby mode after a certain period of inactivity will also be very helpful. Establishing seasonal and weekend shutdown and unplug protocols just in your office among your coworkers can go really far as well without needing to purchase any additional devices or anything. So this is, just establishing a best practice where at the end of the workday or at the end of a work week, and certainly before we go on bigger holiday breaks, you make sure that the devices that you share, whether it's kitchenette devices, printers and copiers, or your workstations, are unplugged simply. And then, the next step beyond that, which I'll talk about over the next several slides, are using advanced power strips. So these are devices that help to de-energize different devices that are plugged into them based on a variety of factors and scenarios. They are commercially available through Office Depot, ODP and Supra, our contracted office supply vendor. This is an example of one of the ones that they have on their website. I believe it's currently $29.99. And we'll talk a little bit more about some of the options there here. So for a power strip to be considered an advanced power strip, it must have features that automatically de-energize plugged-in electrical devices according to manufacturer specifications. And they need to connect and reconnect power according to those specifications. So here we've got 5 examples of different kinds of advanced power strips that might suit different uses and situations. Simple timer power strips can work really well for office spaces that have, just a standard, very regular work schedule. So having it scheduled to turn on at 6 a.m. every morning and shut off at 6 p.m. every night, things like that. Master controlled power strips are APSs that automatically turn off or de-energize controlled outlets where peripheral devices such as a task light or a printer are plugged in. And then when a user turns off that primary device, it'll shut off the peripherals. A masterless power strip is kind of similar, but it just doesn't have that master device. So all of the controlled outlets will shut off when the entire system is shut down. And then we've got remote switch power strips. So if you are, away from your office and you want to turn something on ahead of time before you get there, you can do that. And then there's activity monitor ones as well that will turn on based on detecting activity in the room, similar to overhead lights. A couple options there. And just for a little bit more about how they work. So an always on outlet, these ones are programmed to always be on and are best for devices like ones that you need to have 24-hour service to. So refrigerators, any phone lines that take messages, outside of business hours, or anything like that, or if they're plugged into like your Wi-Fi or something like that. These controlled outlets, the green over there, are outlets that are energized and de-energized according to the control functionality built into that advanced power strip. And then the secondary outlets, the secondary outlets are the controlled outlets. The primary outlet is like that master control that I was talking about on the other slide. So this here is just another helpful tool from the National Renewable Energy Lab that can help you determine which advanced power strip is a best fit for your devices and your habits. So look at this flow chart and think through the devices, let's just say at your workstation for now. So, or just to start, and you can answer these questions to see if you can determine what APS would be best for you. And I should note as well, while looking at this, that there are smart and remote metering, monitoring, and control systems on the market that can integrate plug load control into building automation and energy management information systems. So like lighting and HVAC updates, that would be a facilities and a building management initiative. And they can certainly result in significant energy savings over time. But since today we're focusing on what we can do on an individual level to reduce plug loads, I kind of left that out. of this overview. And that is all the recommendations I have for right now related to plug loads, but I did just want to point quickly to a couple of initiatives that we have or a couple of sources of data and initiatives we have going on. I linked before the sustainability dashboards where you can look up Pitt's energy use and water use intensity in buildings across campus. So definitely I encourage you to check that out. We also just released our update, our progress report on our sustainability plan for the first time since 2018. So it details our progress over those first 4 years. It's available now on our website, and I'll also throw a link into the chat in a moment. But definitely I encourage you to check that out if you want to see in real time how we have progressed on those 68 goals. And finally, like I mentioned before, we are redoing our literacy and culture survey, which we do every 3 years. And this is a tool that we use to make sure that the initiatives and programs that we're putting in place through the Office of Sustainability and through the university match up with what the Pitt community is prioritizing. So that survey will be live through the rest of April. And you can take it and potentially win a gift card. Yay. But mainly, it's great to have your voice heard on all these different initiatives. And then finally, if you're interested after this webinar in figuring out more ways that your office can be sustainable in its everyday operations and practice, I run our university Green Office program. And this is a certification or a designation program that recognizes sustainable best practices that you already keep in your office and to provide you with resources to initiate new practices that you want to take on. So I will put a link in there to this program. We do have a webinar coming up in a couple of weeks, or I guess it's next week, for how to get started in that program. That's this How to Grow Your Green Office virtual webinar on the 18th. And then similarly, we've got a webinar coming up on sustainable purchasing and strategies for circularity to help reduce the emissions related to your purchases on campus and to make more sustainable and equitable decisions there as well. And that's all we've got for the formal presentation. So I'm going to turn off recording and we can get into questions with everyone. Just give me one